Hey guys, I'm here back with another math video. Today we're going to do AIME 2006 number 2, number 5. It's a probability problem. And regularly probability problems turn up a lot in AIME, so I decided why don't we practice some probability today. And just so, look at the problem, read it, pause the video if you need to, and try to solve it. It's not that hard. Well, it's hard for some people. But it's one of the simpler AIME problems is what I meant to say. Okay, so here's the solution. So, without loss of generality, let's assume that f is 6. Without loss of generality, because it doesn't really matter what number you choose, so let's just assume f is 6. And the way you get a sum of 7 is for you to get basically on one die one number and the other die the number on the opposite side. Okay, so let's start out by making the problem simpler. Just obtaining a sum of 7 is like intimidating, so let's subtract some probabilities. For instance, if f is 6 and the other side is like 1, then the other sides all have a chance of having a 1/6 chance of being rolled. So possible combinations are 3, 4, 4, 3, 5, 2, 2, 5, which don't include f or 1. So these all have 3. Sorry, I have a cough. 3, 4, 5, and 2 all have a 1/6 probability of being chosen. So they're all equal to not 1/4 times 1/6, which is equal to 1/36. And when you multiply it by 4. You get, when you multiply by 4, because you have to add all these probabilities together, the probability of getting a sum of 7 using these numbers is 1/36 times 4 equals 1/9. So let's subtract 1/9 from 47 of 288. So when you subtract these, you get the probability, because the probability of getting a sum of 7 from using only these numbers is 1/9. So when you subtract it from the probability of getting a sum of 7, you get 5/96, which is equal to the probability of getting 6, 1, or 1/6. So it's these probabilities. And to multiply to find, because these probabilities are like equal. Because probability, so let's assume the probability of getting 6 on the first die is A6. This is probability of getting 6 on the first die times B1, which is this, and then plus A1 plus times B6. Okay, this is a probability. Okay, so let's review what we did, because I don't want you guys to get confused. So obtaining a sum of 7 is 47/288. We don't want this excess probability of getting a sum of 7 from 3, 4, 4, 3, 5, 2, or 2, 5. So we add all these probabilities of getting these pairs together to get 1/9, and we subtract it from this probability to only leave us with a probability of getting 6, 1, or 1/6 on the 2 die. And A6 is the probability of getting 6 on the first die, while B1 is getting probability of 1 on the second die, and vice versa. And this is the addition of these two probabilities, because that's what we're left with. There's no other combination. So we know that these die are actually these die are equal. So essentially, you could just say A6 times probability of getting 1 on A is equal to probability of getting 1 on B. So it's times A1 plus A6 times B. Oh, sorry, A1. Sorry about that. So remember, the probability of getting 1 on B is the same probability as getting 1 on A, because the probabilities are equal because they're the same dice. And that's the same for the second one as well. The probability of getting 6 on B is the same probability of getting 6 on A. So we're left with this. Probability of getting, 2 times the probability of getting 6 on A times probability of getting 1 on A equals 5/96. And thus equals 5 over what was the probability 192? Okay, so we have this. Now we have to consider the fact that these die are on the opposite side, and because they're on the opposite side, okay, the probability of rolling a number on a die is 1, right? Like you throw a dice. What's the probability of getting a number? That's 1. The sum of the probabilities of getting a number on all the die for all the numbers added together is equal. So basically, what I'm saying is A1, the probability of getting 1, plus A2 plus A3 plus A4 plus A5 plus A6 has to equal 1, because that's all the possible choices, right? A1, probability of getting 1, plus the probability of getting 2, plus the probability of getting 3, plus the probability of getting 4, plus the probability of getting 5, and so on, just equals 1. It has to always be like that. And because we know 4 of these probabilities, because we know, this, and this all equal 1/6, we know the probability of getting this when you add 1/6 plus 1/6 plus 1/6 plus 1/6 is 2/3. So basically, A1 plus A6 equals 1 minus 2/3, which is just 1/3. Okay, so let's move on. So we have these two equations, and we can solve now. So A1 equals 1/3 minus A6. Sub it in. So A6 times 1/3 minus A6. Again, A6 is just probability of rolling 6 is 5/192. Then if you reduce out, you get a quadratic. Let's say A6 just equals x, because I want to write the quadratic out easier. 192 x squared minus 64 x plus 5 equals 0. And you get x equals 1/8 or 5/24. So probability of rolling 6, the prob of rolling 6 is, and here's the thing, it says the probability of rolling f, taking face f, is greater than 1/6. And since it's greater than 1/6, we have to find the greater probability. The probability, and just so you know where 1/8 comes in, 1/8 is the probability of rolling the other face. Essentially, just rolling the opposite face of actually no, sorry, it's not the probability of rolling the opposite. It's essentially, it's saying that f has to equal is greater than 1/6, and 5/24 is greater than 1/6. If it didn't specify that, then we would have two possible answers. So basically, probability of rolling 6 is 5/24, which is cool because such a simple answer. And then the question asks what's m plus n, and m plus n equals 29. So that's our answer. Reviewing, we first found out the probability of just getting 6 on A plus getting 1 on A plus getting 6 on A plus getting 1 on A. 2 times the probability of getting 6 on A times the probability of getting 1 on A is 5/96. Then we found the sum of the probabilities. Then we turned it into a quadratic. And I'm sorry if I wasn't super clear, but I'll try to be better next time. I hope I didn't confuse you guys too much. So hey guys, it's Zong. No, I'm not from the last video. So basically, Daniel and I have gotten our own video recording software and video editing software. So essentially, Daniel and I are going to do the videos from 2 different houses on 2 different computers on our own now, instead of me having to record Daniel every time he does a video. Because of this, the video files are on different computers, and to send last week's video that Daniel did, it would have to require 20 minutes of rendering on his side, and then to send it to me through Google Drive, and then have to take 20 minutes to download it. It takes an incredibly long time. So essentially, from now on, our last videos and our outro will be the last videos that we did. And so this is my last video on the Chinese remainder theorem. If you want to go check out Daniel's last video, it will be about Euler's theorem, I think. So yeah, thanks.